With two muscular solid strap-on boosters, a large liquid core stage, and a homegrown cryogenic upper stage with powerful CE-20 engine, it stands as tall as a 12-storied building. This is the next version of GSLV launch vehicle of India, GSLV Mark 3. From the days of launching sounding rockets in the early 60s, India has traversed a long and difficult path to achieve self-reliance in the field of satellite launch vehicle technology. The know-how and the nuances of this domain are closely guarded internationally and have largely been learned through indigenous effort in a hard way. Crossing important milestones like SLV-3, ASLV, and the PSLV, this difficult road led ISRO to the successful development of Geosynchronous Satellite Launch Vehicle, or GSLV, in 1990s with an aim to develop indigenous capability to launch 2-ton class of satellites into geosynchronous transfer orbit. GSLV Mark I used Russian cryogenic upper stage, while Mark II used indigenous cryogenic upper stage. Mark III, though a technological successor to its predecessors, is in fact entirely different from Mark I and II in terms of its structure, size, and stages. The design of Mark III has been perfected and adapted using the experience gained over time in development of its predecessors. The structure of the Mark III was tested for the atmospheric regime of flight in 2014 when it carried a crew module to a height of 126 kilometers. Both its solid and liquid propulsion stages performed with textbook precision. The crew module later descended to Earth in a controlled manner and was successfully recovered from the Bay of Bengal. The GSLV Mark III D1 mission is scheduled to be launched in June 2017 from Sriharikota. The overall length of the vehicle is 43.43 meters, and its weight prior to liftoff is around 640 tons. The two large solid S-200 boosters form the first stage of this vehicle. Each of these is 25.7 meters long and 3.2 meters in diameter, containing around 204.35 tons of solid propellant. The boosters have a flex seal controlled nozzle which can also be used for steering the vehicle. The second stage, or the core stage, named L110, is around 21.39 meters long and 4 meters in diameter. It carries 112.2 tons of earth-storable liquid propellants. It employs two clustered Vikas engines, each of which are around 2.9 meters long and 1 meter in diameter. The third stage, cryogenic upper stage, is 13.5 meters long, 4 meters in diameter, and contains 27.5 tons of liquid hydrogen and liquid oxygen as cryogenic propellants, which provide higher thrust for the amount of propellant burned. That's why it is more efficient. The technical challenge is to manage the cryogens from their extreme low temperatures to their subsequent ignition and combustion. ISRO's newly developed CE-20 engine is an answer to this challenge. It produces a thrust of around 186 kilonewtons. The encapsulated assembly at the top of the vehicle houses the Payload Adapter (PLA), Ogive Payload Fairing (OLPF), and the satellite. Mark III has a large fairing of a 5-meter diameter and is 10.7 meter long, having a volume of 121 meter cube, sufficient to accommodate large satellites. VSSC Thiruvananthapuram was responsible for the engineering and design of the vehicle. Two major stages of Mark III, L110 and C25, were developed by LPSC Thiruvananthapuram. The flight stage integration of L110 and C25 was carried out at IPRC Mahendragiri. all the stages of the vehicle were transported to SDSC Shar, where these were integrated, assembled, and readied for launch. The first developmental flight of the GSLV Mark 3 D1 mission carries the 3.1-ton GSAT-19, which is a communication satellite having advanced features. The satellite carries multi-beam Ku and Ka band payload to provide high throughput of about 4 Gbps. It also carries geostationary radiation spectrometer to study the nature and characteristics of charged particles. This will help in carrying out continuous long-term monitoring of the geostationary radiation environment and enable the scientists to plan and build future satellite systems. GSAT-19 spacecraft contains several new technology elements realized by various centers and units of ISRO. Space Application Center SAC Ahmedabad has realized the communication payload of the satellite. Two new fabrication technologies, direct metal laser sintering DMLS and aluminium-lined CFRP, are implemented for the first time in realizing GSAT-19 antenna feeds. The Ku and Ka band antennas on board the spacecraft will generate high-gain spot beams over Indian mainland as well as the Andaman and Nicobar Islands. The satellite will facilitate the communication to the user terminals using Ka and Ku bands. The gateways for the satellite are configured in Ka band. An optical fiber link will be established between the gateways for intercommunication. To maintain the pointing accuracy of the spot beams, GSAT-19 has been configured with an onboard antenna tracking system. LPSC Bengaluru delivered propulsion system component. New high-performance AR250 liquid apogee motor, LAM, and modular propulsion gas module are realized by LPSC Thiruvananthapuram. VSSC supplied all the composite elements like antenna, yokes, and substrates for solar panels and pyros. Indigenous 100-ampere lithium-ion battery developed by VSSC and ISAC. All sensors and new technology elements like Mark 3 star sensor, microcast, fiber optic gyros, MEMS-based accelerometer were delivered by LEOS, while IISU provided inertial elements for the spacecraft. ISRO Satellite Center ISAC at Bengaluru was responsible for spacecraft configuration finalization, fabrication of mainframe electronic packages, and also carried out the overall testing and assembly of the spacecraft. Geostationary radiation spectrometer payload was also realized by ISAC. This center also delivered the new technologies like indigenous 70-volt DC-DC converters, indigenous bus bars, miniature heat pipe experiment, and loop heat pipe experiment. GSAT-19 will be launched from SDSC Shar, which will carry out all the launch operations right from the arrival of the spacecraft till its launch. It is configured with chemical propulsion system and will provide a mission life of 10 years. Master Control Facility located at Hassan will be responsible for spacecraft operations right from the launch to its end of life. The Mark 3 vehicle will lift off with a simultaneous ignition of both the solid boosters. At 114 seconds, the liquid core stage will be ignited. At 139.98 seconds, the boosters burn out and separate from the vehicle. At around 224.84 seconds, the payload fairing will be separated. The liquid core stage burns out by 317.12 seconds and will be separated from the vehicle. After 2 seconds, the C-25 stage will ignite and will burn for almost 600 seconds. Subsequently, it will shut down at 964.72 seconds. A few seconds later, GSAT-19 will be injected into a GTO with its perigee at 170 kilometers and apogee at around 36,000 kilometers. Once the satellite reaches its final orbit, the solar panels and telecommunication antennas will be deployed. Light or heavy, putting a satellite into orbit is a mammoth task. It takes a symphony of engineering, mechanics, physics, mathematics, and dynamics to achieve the goal. GSLV Mark 3 D1 will be yet another triumph of our space program's root philosophy, space science to the service of the common man.